Hello everyone, welcome back to the online class of Physics class 10. So we were studying the chapter number 13, magnetic effects of electric current, and in the chapter we have finished up to the right hand thumb rule, which shows the direction of current and the direction of magnetic field lines. If you hold our thumb like this, right hand thumb, fold it like this, then the direction of the thumb shows direction of electric field, and the four folded fingers, the direction of the four folded fingers shows in which the magnetic field lines will move. Now let us see magnetic field due to a current carrying loop, means a circular coil. If we bend a circular coil, if we bend a coil or a wire in the form of a circle, such that this side is having positive and this side is connected to a negative terminal. Means here the connections are made to a battery, to a cell, and it is connected like this. So this side is the positive is flowing from this side, the negative is flowing from the upper part or the upper side. Now in this coil, or since it is a conductor, it will induce or it will get induced some magnetic field. Now the magnetic field will get induced in each and every point of the wire. Till now we have learned about the magnetic field in a straight conductor. When the conductor was straight, then we have seen how the magnetic field lines are related to it. So now let us look according to a coil. Now when the current is flowing from this side, the current will flow from each and every part of the conductor. Like this, the current will flow through the conductor. The current will flow from this side, the current will flow from this side also, and this side also. Now the thing to consider is that in this side and the upper part and the lower part, the current are flowing in the opposite direction. Like in the upper part, the current is flowing in this direction, and in the upper part, the current is flowing in this direction. Same thing goes with the right and the left side also. So here upside, here downwards. Now we don't consider here the right and the left side. We only need to see the upper and the lower part of the coil. Now when the current is flowing through this part or through this coil, it will induce some magnetic field within this wire. Now if we apply right hand thumb rule in this point, means exactly at this point, so here the current is flowing like this and the magnetic field will be in this direction. That means magnetic field will go like this and will come out in this way. Again, just see like this, in this direction, current is flowing in this direction, magnetic field are the four folded fingers. So applying the right hand thumb rule, so the magnetic field will move through inside the conductor and it will come out. So it will go like this. In this way of circular turns. So just in this will be enough. Now in the lower part, the current is flowing that side towards the right, so it will be directed like this. Now let us see at the upper part. Now in the upper part, the current is flowing to the left, towards the left. So the direction of current according to the thumb, this side, and magnetic field from that side is going through the conductor, so it will be moving out like this. this. So just imagine a situation like this. For example, if I hold this bangle, like if this acts as the circular conductor, this is the conductor for example, and in these points if I cut it, just imagine if I cut it from here and connect the points of the terminals of a battery in this way. So in the lower part the current is going that side, so the magnetic field is moving from here, it's coming from inside and moving out like this. And in the upper part the current is flowing this side, so the magnetic field is moving and going through the inside. That means in this side the magnetic field is moving like this, just if you see it like this. So it is coming through inside the conductor like this, or here like this, and in the upper part the magnetic field is moving and going through inside the conductor. Means that going both the parts, the upper and the lower parts, the magnetic field is moving through inside the conductor and moving in this direction. So here the magnetic field will be finally moving like this, like this. It's going through the conductor and coming out. So magnetic field will be moving. This is also moving like this. So as a result of this, the magnetic field is moving through inside the conductor, through the circular coil, means from inside the circular coil, from one side to another. So we know inside the magnetic field goes from south to north. So this side will be the south pole of the coil and this side will be the north pole of the coil. So as a whole, this coil will act like a small piece of magnet. So this is like this. So once again, just look at this bangle for understanding. So if this is the coil, the current is flowing from here in this direction. Then in this part the current is that side. So magnetic field will move from inside this part, and in the upper part the current is in this side, means towards me, towards my face. So the magnetic field lines will move like this. So as a whole, the magnetic field lines will be moving from my arm, means from my ankle, from my arm towards the camera, means it's going through the conductor like this. So this is how the magnetic field is related in a circular coil. Now if we take so many circles, means instead of taking one coil, if I take so many circular coils like a spring, so let us see what happens with. So if I have a coil with so many circular turns, for example, this is a coil having so many circular turns, and in this coil, the coil is connected to a power source, a key, some resistance, and finally this, for example, this is our circuit. So what will happen? This is the positive, this is the negative of the battery. So current will flow like this towards here and here. Then the current will flow through the coil. And likewise, we saw just now that when current flows through any coil, it produces magnetic field within the coil. So this side the current is flowing in each and every point, the current is flowing to another side. So here the current is flowing like this, and by the same way the magnetic field will move through inside the coil and will complete its arc and come back to this side. Just removing this part, not required. Applying the same right hand thumb rule in this part also. So the magnetic field, like if you are looking at this point, for example, the current is coming like this and going like this. So here the field is like this, and in this point the field is like this. So according to this, the magnetic field will move through inside the coil like this, and will move out and again will come back inside the coil. So magnetic field lines will move through the conductor in a circular manner. Like this, magnetic field lines will move along the conductor. So finally this side will be the south and this part will be our north of the magnet. Magnetic field line will move through inside the coil, and this coil, the coil having number of turns, is known as a solenoid. And rubbing this part, this coil is known as a solenoid. So solenoid can be also told or can be also said as an electromagnet. So when current is passing through the coil will act like a magnet, and when the current will stop, the magnetic field will also stop within the coil. So these types of solenoid or these types of coil act as an electromagnet. So electromagnet is a device which acts like a magnet when electricity is passed through it, and when electricity is stopped, the magnetic field also finishes, or the magnetic field also stops through the magnet, through the coil. So this type of coil is known as a solenoid. Now inside a solenoid, the magnetic field is due to the current in these loops. I rub this part, only this part for understanding. For example, if you look at this loop, the current is flowing down. So here magnetic field that side, and in this part the current is flowing up. So the magnetic field is like this. That means it's going through inside the loop and finally out of the loop like this. Now in a solenoid, the strength of the magnetic field can be increased or decreased. So if the number of turns is increased, then the magnetic field of the solenoid also increases, and if the number of turns is reduced, then the magnetic field is also reduced. It also depends with the current or the voltage of the power source basically. So mostly the number of turns, the total number of turns in the solenoid determines how strong magnet it will be. This was only for today. Thank you.